Hello? Hey, sorry about that. Um, I'm not gonna do another take on this because I've done 3 takes. I'm going to stick with this one. So hey everyone, I've been busy working on a lot of GRE things for graduate school for architecture and working on my portfolio. And I actually may make a video on how to create a portfolio for designs and things like that and what you should do. Um, but that's only after I'm done making the portfolio. I'm not going to do it in the middle and then start tutorial when when I don't really know what I'm doing as well. I want to have a full picture before I make a video on something. So the video is there to reinforce the knowledge I already know, not just add, in my opinion. So anyway, so I've been playing around. I've been busy, but I had some time, so I thought I'd make a video on something that I was just working on. It's on a map to surface and using map to surface and surface morph. This is the tutorial on that, and I'm very excited to do this. Um, I got it working. This is inspired by. I'll post a link in the description. I don't want to turn on my browser because I don't have enough RAM on this computer to actually run Chrome at the moment. So, but yeah, because my RAM count is really bad right now. It's like I'm already almost taking up half of it. But so yeah, we'll start. This will be based off just. This will be a tutorial on how to use surface morph, and I will be using the Voronoi pattern. I think that's how you say it, Voronoi. I'm gonna have to look that up. I did look it up and try to understand the pronunciation, but I'm not very good. So I'm gonna call it the Voronoi pattern, and I apologize if I say it wrong, but that's how I'm gonna say it. Also, if you hear that kind of humming, buzzing sound in the background, that's my 3D printer running. Um, right now, the print's gonna be a 17-hour print, so it's gonna take a while. If you can't hear me, I apologize, but I'm trying to speak closer to where the mic is at on the computer, so you guys can hear me. And it seems like that's what it's working right now. So yeah, let's get started. So I just created an arbitrary surface. So what I would do is just create any arbitrary surface. So I created this. I just used literally 2 curves and then another curve and then lofted them. That's literally all I did. So what you're going to do now is reference the surface. So I'm going to reference this. Set one surface. Stepper motors on my 3D printer are going crazy. So what I like to do usually when I make my objects, so I like to hide it, and then so I only left with this surface, and I don't mess up my geometry by moving it if I need to. So if I don't need to, so I can always say show if I want to show it, but for right now I'm going to keep it like that. So what I'm going to do now is do what I usually would do. Well, let me think. So I reference the surface. So when I reference my surface, I want to create the Voronoi pattern. So actually, let me show it one more time because I'm going to need this on here. So what I'm going to do is I'm going to go in top view, and I'm going to do a surface point. So this is the way I know how to do it. I did look up another way to do it, but I don't like it, so I'm going to do it the way I know. So so what I did was I went in top view and traced this surface out. So another way you can do this is also do a make 2D top view, and this will create the line work of the edges. Or you could do a select boundary surface. Not select boundary. You could do what's it called? Dupe border, and then do make 2D, so you get a perfect. But this looks good, so we're gonna stick with this. So let's click that, and now we have our I referenced my surface, and now I did. Let's do curve as well. How do I solve curve? Join them. Sorry, I usually it joins them, so that's kind of weird. So one curve. So hide. I have my curve, right? Let me check. Yes, I do. Let me actually show my curve, and I'm gonna bring it up actually, and then cell all hide. All right. So once you have your stuff, we're going to be using this curve for majority of it, but we will be using the surface, so it was good to reference it anyways, just to have it. Since we're going to be using that mostly, I'm going to put the surface on the bottom, and then we're going to work with this curve. So what we're going to do is we're going to populate 2D and do the region, and the counts will be 50. I don't want that many, just to make it simple. Once we do populate 2D, I just made mine 50. You can also change these variables if you want to. This changes the randomization of it, and this is like using a pre-existing population to influence it, but we're not doing that. This is simply more for how to use populate, how to use surface morph. So once we do that, we're now after that we're going to use a Voronoi pattern. So Voronoi, yeah, okay. And then we're going to do points radius dot boundary, and then we're going to plug this in, and then we're going to plug in. So now you see it created the Voronoi pattern, but it has all these like kind of strange stuff. Right now the boundary is some random empty container or something. Oh, sorry, I got a notification. So then I'm going to plug this into the curve, and then that's it. So that's my boundary. So we picked this curve as our boundary. And I can add more points. No, I'm fine. A radius, let's see. When I change it, what does it look like? Starts out as circles. So I have that. I'm just going to stick with 6. And that should be good. Optimal grouping. If no planes are, then best fit plane will be used. Empty plane parameter. Maybe this will make it a little more even? No, whatever. Okay, so anyways, so what we're going to do now is we're going to do a... After we do this, sorry, I'm blanking out right now, because once we have the cells, we now have these like kind of pre-existing objects. Once we do that, we can now do a offset curve. Now we could do this offset curve. I did look up a video on a better offset curve type of command. It's a Python, a very, very short Python script. I will link to the video in the description. It was super helpful. I subscribe to his channel because his channel is super helpful, and I think he provides really good content in terms of Grasshopper, Houdini, and a lot of other kind of design CAD softwares that are computational. They're really good videos, very well thought out, and he definitely knows his stuff. He's way better than me, like 100 times better. He's super smart, so I will leave his in the description gladly. He definitely deserves all the praises for what I just gave out. So we're actually going to do, instead of a regular offset like this one, we're going to use a GHPython. So this is from his video, and he does the exact same thing here, but I'm going to go over it real quick. So what we're going to do, we're going to rename these. We're going to add another variable, so x, y, and z. We're going to rename the x curve, so you can do either type in curve or do CRV, either one. I'll just do the full name because I like the full name. Helps me out. This will be direction, either dir or direction, and then you can do distance. So this or distance. So once we do that, you can either do that. Actually, I think there's a reason why he named it CRV. Let me do this. I think there's a reason. I don't think this affects the script, but I am going to try. I'm going to keep it the way he has it, just for the sake. So double click to open up your script. Right now this script is empty. So what you need to do now, you see your Python script. Hit enter twice, and then you're going to do a space equals rs dot, and it's going to pop up with all of these type of commands you could ever use. So we're going to be using offset curve, and then we're going to parentheses. There's parameters that we can use for offset. There's a ton of them, like chamfer, all these other ones. But we're going to be using CRV, direction, and distance. And then we're going to hit test and OK. Now it's going to fail because there's nothing plugged in. So if you click this, it'll be like input, and there's nothing to guide it. So we're going to do curve, the direction, which should be these points, because usually this is really means center point. The direction is really like the center of it, and then the distance. So we're going to pick 0.25 for right now, just to make things simple. And there we go. Wow. And you get a perfect, what's it called? A perfect offset. So you can play around with that, and you can get your perfect offset. So this is better offset. And I'm going to do that for all my offsets because it makes life super simple, and sometimes it offsets wrong with mine, so with the regular command, so I'll be using this. It's actually really cool. And so shout out to that guy. Again, I'll post his video link in the description. Really, really cool. So anyways, and also I don't know how to code very well, so that's why I thought it was cool. But anyways, so let's get started. So what I'm going to do now is take these two and do a region difference, because I'm using this region difference in order to make kind of a thin surface. Like these will be individual surfaces instead of it being one surface. So if I did a boundary surface right now, it would just be one whole thing. So it would just be one big surface. So what I want to do is I'm going to take the bigger and then the offsetted and then combine them. So this seems like it graphs it all, I am assuming. Or wait, oh, I mean, you plug it in here. Yep. All right, cool. And plug in the A. And let this thing. Wow, my computer really likes to crash a lot. It's just a thing. I'm not too sure how to fix it. And then I flatten this. The reason why I'm flattening it is because I want these two to read the same. So this is flattened, and this is grafted. So I'm going to flatten this. I could, I guess, graph this as well, but, I mean, yeah, I chose to flatten it. So either way, you could graft it or flatten it. Graft this or flatten this, one of the two. So now once you do that, when you do boundary difference or boundary surface, it should work. Yep, and now we get that individual kind of line surface. This point looks like the most kind of centralizing. But anyways, I don't know, I just thought it looked. So anyways, we take that, and I'm going to perspective now, and look, so I'm going to now project, not project, I'm going to do a surface morph. Morph. There we go. There it is. So now it asks for all of these things, a U, V, W. So my W always going to remain 1. That's how you should be, and that's how it should be. And this can be whatever for right now. For right now, we're not going to put anything. But we're going to keep our surface morph here, because I forgot there's one more thing I need to do. When you do a bounding, because you need to do a bounding box, because it asks for a reference. So you need to do a bounding box for all the kind of surfaces you have. But the problem is when you do a content, and this needs to be changed to union, by the way. And then I think this is pre-flattened already. I think this is already under one list, quote-unquote flattened already. It is. But I'm going to flatten it anyways, because usually you're supposed to, this is always supposed to stay under one list, so I always flatten it out of habit. Technically I didn't have to, but I did this time. But when you do a bounding box, the volume of the box is literally 0, because these are just surfaces, and surface is a non-zero thickness, or a 0 thickness material in the computer space. So what you need to do actually is do an extrude, and then pick a unit. I pick Z, factor of Z, pick a number. I picked 1, and then base, and this should extrude up 1. And then now you put this into the box. Now once you have that, you now have your bounding box, you now have the geometry you want to morph, and the surface, which is down here. So I'm going to plug the surface already into here. These UVs I'm going to create as 10 by 10 for right now. Or actually, not copy and paste. These will be shared by the same units. So now it's asking for a reference and the geometry to deform. So I want to deform this geometry. Right? Let me see. Yep, correct. Sorry, excuse me. This geometry. Technically, I could use this geometry. Like, I'll keep this in for right now, and I can do a box. And let's see how this goes. So right now it's pretty tiny. Yeah, it's really tiny. So we're going to scale this up hardcore. So we're going to change this range to 1,000. It looks like it's going to be pretty huge. And we're going to make the numbers around 150. And then you're going to see it embiggen. So this won't match exactly to the form of the surface, unfortunately. But you see, it's matching. This is the surface. It's matching to that. What you can do is, what's it called? You can make it like a square at first, and it will match not perfectly, but it'll match very close to this. If you just want it to morph to most of the shape, it doesn't need to be exact, then that's fine. I think that's how it should be. It doesn't have to be exact. So what I would do instead, so right now I have this surface, so I like to do less work. So what I would do is just plug in the extruded one and plug that in, and it'll transform that W into 1. And now you have that. Now we're going to make this 300. So we're going to double it. And I'll see what it does. That looks pretty good. And now let's just do 400. This will increase it again. And now, let's lower that to 380. So that's how you use it. You pretty much use these UVW domains as a way to reference them. You can use, I think it's easier just to keep it a square instead of it referenced as this kind of weird wonky shape because it doesn't really fit very well. But yeah, I think this looks pretty good actually for, what's it called, for being just done right here. So I'm going to bake this real quick. If you don't want to be, you don't need to be absolute exact. That's fine. I think it doesn't need to. If you want it absolutely exact, what I would do is just keep the as a square. So what I mean by square is, so this is what I have right now, and I think that looks pretty cool. So it wraps around that surface in terms of that shape. You can also use the Voronoi and actually like fillet all of them, or not round them. Use a fillet, cells, fillet, and then you can do the same thing here, fillet the same amount. But so we don't have to use this curve. Technically, you can use another curve. You can just do really any curve. You can just do this rectangle, or you can make a rectangle here and do it. But I like to do it in Rhino. I don't know, just how I am. Depends. If I'm the only one using the script, I will just reference it. If someone else is using it, I will make it as much as I can in Grasshopper, because that's the way to do it. So let's put this as the region, and the boundary, and the plane. Right now it's lagging a tiny bit, but that's just how my computer is. Now I want to see what else is connected to. I don't know exactly. Bless me. I'm sorry. So right now, as you can see, it once it's squared, it actually like matches pretty well with the surface. But as you can see, the scaling is off. So let's go in the top view, and now let's just scale it to 330. That looks pretty good. That looks pretty good. I think that looks pretty good. That's pretty good scaling. And if you want to go even more exact, you can do is copy and paste, plug this into V, and then or UV X, Y. Yeah, okay, so I did this right. So, and then 350. Or did I do this right? Oh, chunks. Okay. I'm going to change this back to 330. Now, why did it freak out? What's going on, man? Alright, whatever. Still working. Whatever. 350. I don't know why it's red. It works. I don't understand. So this is 350. Where's the surface at? $340. And that fits pretty well. So I think that fits pretty well. Let's bake this and see how this looks. Wow, that looks really good. I'm pretty happy with that right now, actually. So what I would recommend doing is making a rectangle out of it, and it'll morph kind of exactly to that shape, which is really cool. So let's go top view and look at this kind of pattern. We can also kind of stand it up to act like as a wall, and we can actually just zoom this in all the way. We don't need Grasshopper right now, and we can turn this on to rendered mode. And I'd say that looks pretty cool. That looks really nice. And not the actual Voronoi. That does look nice inherently, I think. But I think what makes it look really nice is just the kind of curvature it mimics right here. Now, there are definitely other ways to do this. I always find it... This is the way I figured out. It's called the projection method, where you just... For me, I didn't make this method up. I discovered it. Doesn't mean I'm the first one to actually figure this out. I highly doubt I'm the first one to figure this out. This program's been around forever, so there's no way. But I usually like to create my complex geometry separate. So what I do is I always make the patterning in two-dimensionally, and then I always project it down. Either project it down or surface morph it. So yeah, I will definitely be using surface morph a lot more often in my architectural work. It's a really cool feature, and I really like it. So yeah. So yeah, guys, that's pretty much it for this tutorial. So I will see you guys later. Thank you guys for watching. Hope you guys have a great day. I will definitely be making more videos. But yeah, I would say this is pretty successful. Again, as usual, the script will be in the link in the description. And I will probably replace these with actual nodes so you don't have to download the Rhino file. But yeah, guys, thank you guys for watching. Have you guys a great day. Bye.